The great North American mammoth and its cousin, the mastodon, the ginormous great sloth of North America, and everyone's favorite, the saber-toothed tiger. Toward the end of the Pleistocene, North America lost 37 mammalian genera, including over 70% of its megafauna. The causes of these extinctions have been debated for centuries, with human hunting, also known as overkill, and the ecological effects of climate change as the most cited principal drivers. Although much effort has focused on the chronology of extinction, far less attention has focused on the population dynamics of humans and megafauna during the millennia preceding these extinctions. In this video, we will focus on the dynamics between humans and megafauna populations to see if we can finally find an answer for whether or not humans or climate change are responsible for the extinction of North America's megafauna. There is no doubt that humans coexisted with megafauna. Sample sites document a clear role in the utilization of megafaunal taxa, with 80% of those sites containing mammoth remains. But instead of looking at data of the extinction of North America's Pleistocene megafauna across the whole continent, we will focus on a region by region basis. Let's start by observing trends in the southwestern United States. Here we see the sloth populations bust during the early Younger Dryas, shortly before a human population decline in the same region. Therefore, the relationship between human and sloth is a positive one. This means humans cannot be responsible for the extinction of the sloth in southwestern United States. This must be the case since if human populations were declining, then and humans were hunting sloths, then the sloth population should have increased. Yet human and sloth population are increasing and decreasing together. This is what I mean by a positive relationship. By contrast, mammoths in the southwestern United States exhibit a negative relationship with humans. This means that as human populations grow, mammoth populations decline. This could indicate that humans are responsible for the extinction of mammoths in the southwestern United States. But is this true for all of North America or just the Southwest? Well, if we observe trends in the Great Lakes, we see that mammoths and mastodons show a positive relationship with humans, meaning humans cannot be fully responsible for the extinction of these two animals in the Great Lake regions. But how should we interpret these data? If clovis hunting truly drove extinctions, then megafaunal population decline should occur during clovis times and be associated with increases of the human population. In other words, for overkill theory to be true, a negative correlation should exist between humans and megafauna populations. By contrast, if climate change drove extinctions, then megafaunal decline should align with climatic and environmental conditions that negatively impact large herbivores. Furthermore, human and megafauna populations. These analyses suggest that a taxonomically and regionally diverse set of factors drove Pleistocene megafauna to extinction, meaning it was neither humans nor climate change, but both, and sometimes in different regions added by. These analyses suggest that a taxonomically and regionally diverse set of factors drove the Pleistocene megafauna to extinction. The cause for mammoth, horse, and saber-toothed extinctions on the contiguous United States is consistent with the activities of Clovis hunters. But we can't say the same about the great ground sloth, which is interesting since the great ground sloth was such an abundant animal in the Pleistocene landscape. But just as important as it is to focus on the animals that did not survive, it is also important that to focus our attention on the animals that did survive and why. For example, bison, sheep, deer, elk, and moose that can efficiently detoxify and utilize plant nutrients in shorter growing seasons survived the wave of extinctions. And unfortunately, mammoths, sloths, and horses that possess more unique digestive anatomies could not survive. So, in conclusion, humans seem to be responsible for the extinction of some animals and in certain regions, but not of all megafauna across the entire North American landscape. While climate change is responsible for the extinction of some animals in some regions, but not across the entire North American landscape, and in some regions, climate change and humans work together to drive these animals into extinction. But there is another cause for extinction of these great animals that we have not mentioned. Yes, there is a third cause for the extinction of megafauna in North America, and that cause is the North American bison. That's right, the bison is not native to North America. Bisons are relatively recent immigrants from Eurasia and are aggressive, highly fecund, and herd-dwelling. Bison also exhibit a population boom during the early Younger Dryas. Now, I love the North American bison. It's a beautiful animal. But there is the possibility that the bison dispersal into North America may have outcompeted out the other megafauna for food at a time in which that megafauna was already being restricted by climate change and human overkill. So here is my second conclusion. There are not two but three factors for the extinction of America's megafauna. One is human overkill, the other is climate change, and the third is the arrival of the American bison. Working together, the megafauna of North America simply did not stand a chance.